Hey, grade 9s, guess which topic we're starting today? You're right, squares. We're going to be looking into different properties of circles. We're going to start today talking about the tangent of a circle, and then we'll look at things like chords and angles as well. Those are the three things we're going to look at. I mentioned before that this topic is simpler to work with because there's an order, there's a list that you can make of different rules that you need to follow. But the fact is you need to practice with those rules in order for this to actually to have it make sense. So yes, it's simpler to work with, but you need to put the work in order to understand it. With your work as well on circles, I'll be posting up the circles so you don't have to draw them out because I'm using technology to give me circles as well, so I don't think that you need to be drawing them out. But let's start with tangents. So a tangent to a circle, it's a line that only touches the circle in one spot. It's basically a line that's going to move along somewhere. It could move anywhere, but it's just barely going to touch the outside of the circle once. What I've drawn on this circle is one tangent line. You could have an infinite number going anywhere you want. I've just drawn one on this side, and it only touches at one point. And that point I've labeled as point P. P stands for the point of tangency. I've also labeled my circle with O in the middle. That's called the origin, always. The origin is always the middle of your circle. So there's a point in the middle, which is O. There's a point on the side, which is P. And then there's points A and B, which are just points on the line of tangency. There's one other line that you know of already, and this is called the radius. The radius will always be a line from the origin to any point on the outside of the circle. And that line can go in any direction. In fact, it can connect your origin to your point of tangency. Do I have to tell you that you have a radius in a problem? No. You need to start recognizing when you have a line that goes from the origin to any point on the outside of the circle that you have a radius. That's going to help you solve problems a little bit later on. Now, Mr. K, we've just drawn a bunch of lines and labeled a circle. How's that solving anything? Well, we have to start to understand some of the math with circles. Circles are really special because interesting things happen when you draw lines or shapes on your circles. In this case, there's one thing that stands out to me that we haven't labeled just yet. And that's at the point where the radius and the point of tangency meet. What we say is that the radius bisects the tangent line. And the word bisect means that we're splitting it perfectly in half. This will always be true when a radius touches a point of tangency. And what that creates is two 90-degree angles on either side. Why is this useful to us? Well, now I can start giving you problems where I can start drawing shapes using my circle, and using the rules that you know with your circle, you should be able to give me some information if I'm looking for it. In this case, I'm looking for angle X. What is the measure of angle X? Well, if I've given you this one, so I've added this 40 degrees in here, and if you know that you have a radius that bisects your tangent line, you have a 90-degree angle in the middle. You can also use your rule for triangles, where all angles in a triangle always add up to 180. And if that's true, well, you can take 90 plus 40, which is going to give you 130, and the remainder is 50. 50 plus 30 gives you 180. So you can figure out that X must be 50 degrees. So we worked through using new terms, so things like bisect, tangent line, point, and tangency, and some old terms, so things like origin and radius, and then understanding that triangles, the angles add up to 180 degrees, to build a problem that you might see. Now, if I was to show you what the problem actually looks like, it'd be something like this. You would need to figure out the missing information just by being given an image like this one, and that's what circles is all about. So I'll give you some practice, particularly dealing with tangent lines, and then next time we'll look at a couple of other types of rules and things that we can find in circles. I want to add to the last lesson as well, and to show you that we previously solved for an unknown angle, but I can ask you to solve for unknown sides as well. I didn't put that in the video because we did that the very first unit. Remember, we dealt with a bunch of three-dimensional shapes, surface area and squares. Same idea though. You know some formulas with triangles, in particular a squared plus b squared equals c squared, the Pythagoras equation. You might need to use that to solve for some missing sides. What does one of those problems look like? well, maybe I'll add an extra line in place there. So I'll say that this line is 4 centimeters, this line is 3 centimeters long, and I'm asking you to tell me what the distance of y might be. And you'd have to solve this by recognizing that, hey, this line down here is a radius, which means that all of my radii must be the same length. And you'll be able to determine that the blue line, P to O, because that's also a radius, will also be 4 centimeters. And if that's true, you can do a squared plus b squared equals c squared. Rearrange your formula, you get the square root of 3 squared plus 4 squared, which ends up being the square root of 25, which equals 5 centimeters. So just another way that you can work with what look like very simple problems, but we have to use a lot of our brain to understand how we can use different parts of our picture to solve the problem.